Section 1.4 in Larson textbooks, and which is the same as section 2.2 in Nagel's textbook. This is called separable differential equations. They're not necessarily linear ordinary differential equations. So here's the definition. A first order ordinary differential equation is separable if it is in this form: P of y dy dx equals q of x. So separation of variable is pretty much the same as saying what? Put the q of x where on the side where dx is, and keep the dy on the side where p of y is. In other words, dy goes with the function of y, and dx goes with the function of x. And then you are ready to attach what? Antiderivative sign, and then you solve what? The equation. So these are extremely easy type of problems. So the idea is they are called separable. In other words, you can separate the variables. So once you put the dy on the side where py is and dx on the side where q of x is, this is known as separation of variables, right? So let's do a problem. The question is solve this differential equation, first order. Notice this is separable. The way you know it's separable, there should be no plus or minus between the x's and y's. So the way we separate it, I'm going to keep the what? 1 plus y squared on this side. Then I'm going to multiply dx by the other side. So this is known as separation of what? Variables. Correct? Once you separate the variables, you put the dy on the side where the function y is and dx on the side where function x is. Now you are ready to integrate. The left side is easy because that's y plus y cubed over 3, but the right side requires what? Integration by parts, correct? By parts. So the way we do this is let u be x, dv be cosine of x dx. So du is dx and v is equal to what? Sine of x. So this would be uv, which is x sine of x, minus v du, which is antiderivative of sine of x dx. So we get y plus y cubed over 3, x minus what? Sine of x minus antiderivative of sine is minus cosine, so that makes it positive cosine. Don't forget the c. So here is the implicit what? The form of the solution. So remember, we call this implicit form because you cannot isolate the equation for what? Y. So this is the solution, which is our final answer. Very nice. So the next one, y prime, remember this is the same as dy dx minus 2y squared x. Separate the variables, so this is called separation of variables. Okay, so what that means is put what? Divide both sides by what? Y squared. Multiply both sides by what? Dx. So now that you have separated the variables, so I'm going to write this as what? Y to the power of negative 2 dy equals negative x what? Dx. So I'm ready to attach the integral sign. Keep in mind you cannot integrate unless you separate the variables. So now this is y to the negative 1 over 1. This is minus x squared over 2. Don't forget the c. You can also rewrite this as negative 1 over y equals negative what? X squared over 2 plus c. But then you can multiply both sides by negative, so you get x squared over 2 plus c. Remember, multiplying a constant by negative still is a constant. So now you would reciprocate this. Y is equal to 1 over all of these. Do you see it? Then you can kind of like make it look nice, multiply the top and bottom by 2. So you would end up with 2 over x squared plus c. So we still got a c. So either of these answers are correct. But sometimes they want you to express the answer in explicit form. So this is explicit form, correct? Explicit form. The next problem is this guy, dy dx equals 2x times y minus 1 over x squared plus 3. So separate the variables, divide both sides by what? Y minus 1. And multiply both sides by dx, like so. The minute you separate the variables, notice the way I know this is separable because there is no plus or minus between the x and y. Integrate. So this guy, if you let u be y minus 1, du what is equal to dy, correct? And therefore, that's in the form of what? Du over what? U, which is natural log of what? U. So the left side is natural log of y minus 1, absolute value. And the right side of u is x squared plus 3, du is 2x dx, which you have it on top. So the right side is natural log of x squared plus 3 plus c1. Notice I did not put the x squared plus 3 inside the absolute value bars because it's a positive quantity. So question is there any way we can what? Express the solution in explicit form? What you do, you exponentiate both sides. So raise both sides to the power of 2, e to the power of both sides. So that's called exponentiate what? Both sides. Okay, exponentiate both sides of the equation. So there. So on the left side, you get absolute value of y minus 1. On the right side, you get e to the c1 times e to the natural log of x squared plus 3. Keep in mind, when you have e to the power of x plus y, you can split it as e to the x times e to the y. Okay, you can drop the absolute value bars. Then you have to attach plus or minus to the right side. And e to the power of natural log of something is something. But I'm going to call this guy a capital C. So that's y minus 1 equals c times x squared plus 3. Then I'm going to add 1. So the final answer in explicit form happens to be this guy. So this is called explicit form, whereas this solution right here, before we exponentiated, it was called implicit form. Do you see it? Remember I said sometimes you should look for plus or minus between x and y. But even though there is a minus between what? X and y, chances are I might be able to separate this. How about if I write this as dy dx? Remember the identity for cosine of difference of two angles is cosine x, cosine y, plus sine x, sine y, over sine x, sine y, minus 1. But then I can split this and write this as what? Cosine x, cosine y, sine x, sine y, and this guy divided by denominator is 1, and guess what? The 1's cancel. So now you have dy dx equals this guy. But now I'm going to write this as dy dx equals, because there is a multiplication, so I get to divide like this. So that would be like what? Cotan of x times what? Cotan of y. So now if you separate the variables, so that would be like what? Cotan of y is equal to cotan of x dx. Okay. Remember cotan, this is cotan of y dy. Cotan of y is cosine of what? Y. Is that right? Divided by sine of y dy. And that's cosine of x divided by sine of x dx. So if you let each of these guys to be the denominators to be u, du is on top. Notice if u is sine of y, du is cosine of y dy. So this guy is natural log of absolute value of sine of y, and this guy is absolute value, natural log of absolute value of what? Sine of x. Don't forget the c. Okay, so now the idea is you can, you should be able to, is there any way I can write this in explicit form? Well, that takes a little bit of work. Exponential at both sides, so you get this. Okay. Now separate the powers on the right side, so that's e to the c1 times e to the power of natural log of sine of x is just what? Sine of x. Well, you kind of get absolute value. Here you get what? Absolute value as well. But if you drop the absolute values on either side, you get plus or minus e to the c1 sine of x. So now call this plus or minus e to the c1, which happens to be constant, a capital C. So sine of y is equal to c sine of x. So y is equal to what? Sine inverse of c sine of x. And this is called what? Explicit form. Explicit form. So notice there's a little bit of manipulation involved, but at the end of the day, sometimes, not all the time, you'll be able to express the answer in explicit form. Sometimes you don't have any choices, so you just leave it as. Okay, this problem right here is solve this separable differential equation. I know it's separable because there's no plus or minus between x and y, but then you have an initial condition. So that means you get to find out what c is. The way I do this, I go x squared plus 1. I'm going to write y prime as dy dx. Okay. Then I'm going to move this guy over to the right side, you know, the y squared guy. Okay, then I'm going to separate the variables. So I'm going to write this as dy over xy squared plus 1. Don't forget the minus. And then that would be dx over x squared plus 1. In other words, keep the minus. Well, this is what I did. Factor out the minus. Okay, divide both sides by y squared plus 1. Then multiply both sides by dx and divide both sides by x squared plus 1. So when you integrate, on the left side, believe it or not, this is tan inverse of y. And on the right side, you get what? Tan inverse of x. Don't forget the c. To solve this equation, we take tangent of both sides. So you get y is equal to tangent of this whole shebang, which is negative tan inverse of x plus c1. So that would be like in what? Explicit form. Do you all see it? Right? So if you got tan inverse, you just take tangent of both sides. But remember, this is not tangent of this guy plus tangent of that guy. This is the entire argument. This is like your entire theta. All right. Here is an example of application example of why do we care about differential equation in geometrically. The question is, find the equation of a curve which passes through this point and whose slope as at any given point is x squared plus y squared. So here's a curve, right? Passes through this point. And the slope of the tangent line to what? To this so-called curve is given by this. Remember, slope is the rate of change of y with respect to x, which is the same as m, which is the same as dy dx. In this case, it was given to us as x squared y squared. So the idea is, how do you go from slope to the curve itself? In other words, I'd like to find the equation of this curve. Yes. So I separate the variables. I divide both sides by y squared, multiply both sides by dx. So that's y to the negative 2 dy, x squared dx, integrate. So you get y to the power of negative 1 over 1. That's x cubed over 3 plus c. That's negative 1 over y plus what? X cubed plus c. That's over 3, of course. Then you multiply both sides by, what is it? Negative 1, you get what? Negative x cubed plus over 3 plus c. It would be nice if you kind of find out what c is at this point. Remember, the point is negative 1 for x, well, 1 for y, so that would be negative 1 over 1. Negative 1 cubed, that's negative 1/3 plus c. So that would be like negative 1 plus 1/3 equals c. So c is equal to what? Negative 2/3. So therefore, what we have is 1 over y, what? Equals negative x cubed over 3. Don't forget it's negative what? 2/3. So if you kind of add these fractions up, you get negative x squared minus 2. Reciprocate the fraction, you get 3 over x squared plus 2, and that would be like what? The equation of this curve, which has a slope of x squared y squared, and it passes through this point. So if you stick this point here, you get what? That would be 1, that's 3, let's see now. Okay, negative, okay, okay. So we found c is equal to negative 2/3. So if you substitute it right here, you get negative 1 over y equals x cubed over 3 minus what? 2/3. But now if you kind of combine or add these fractions, you get what? Positive what? X cubed minus 2. But if you remember, there's a minus here. So if you multiply both sides by negative, so that guy becomes negative x cubed positive 2 all over 3. Reciprocate the fraction. The final answer is positive 3 over negative x cubed plus 2. Notice the initial condition satisfies. If you replace this guy with negative what? 1, negative 1 cubed is negative 1 times negative, that's plus 1. 2, that's 3, 3 over 3 is 1, so it checks. Sometimes it's kind of like what? Hard to solve the problem, so you have to do the problem sometimes, not all the time, by inspection. Notice the idea is what? You have this differential equation. Would you be able by inspection tell what the answer is? Well, it turns out the answer is y is equal to 0, and it pretty much satisfies that equation. Why? Because y prime is 0, and if y is 0, you get 0 equals 0, which checks. However, if you attempt to solve this, you get dy dx is equal to y cubed sine of x. Separate the variables. So that's dy over y cubed equals sine of x dx, which is the same as y to the power of negative 3 equals what? Dy sine of x dx. Integrate, you get what? Y to the power of negative 2 over negative 2 equals negative cosine of x plus c, which is the same as what? Excuse me, 1 over 2 y to the power of 2 minus cosine of x plus c. But remember, the minute you stick 0 here, you get undefined. So notice this kind of gets you to Neverland. So therefore, it was kind of like done by inspection. When the solution is constant, we call these guys singular solutions. Singular solution. Do you see it? And that's pretty much the gist of this section. And I will see you in the next video. Thank you.